So for this number 23, I found the amplitude is the number in front of the cosine. That's negative 11. Amplitude is flipped to 11. The number in front of the x in the function is your b value. 2 pi over that is 10 pi. There's nothing subtracted in the function or added or subtracted outside, so there's no shift. So now you just start by drawing the cosine. I'm just going to go up here. I'm going to come down here, go down there, up here, like that. And this is going to be at 11 and negative 11. Except what does it do? Flips. So I'm going to flip that like that. And then the period is 10 pi. So that means that one complete cycle is 10 pi. Half of that is 5 pi. Ta-da! Done. Should we do the tangent one? Do the tangent one up here. So, Kate, what is A in this one? 2. And then, let's see, I have Masha, what is the B value for this one? What's in front of the X? 1/4. So that's going to go here. And then this, nothing is subtracted. And D is going to be minus 3. So that means it's going to go down 3. There's no shift. For tangent, how far from asymptote to asymptote? Pi. So this formula isn't 2 pi over b, it's pi over b. Or pi over 1/4, which is 4 pi. Oh, I like that. Amplitude is 2. Great. So let's put up our force fields. I'm going to put one force field here and one force field here. And from here to here is 4 pi. That's what the period is. So if this is 0, what will this asymptote on the right be at? 2 pi, and the one on the left will be at negative 2 pi. Does that make sense? Huh? Yeah. All right, so then you're going to sketch your tangent curve. how to analyze something that's of the form seco cosi. Oh, wait, I did. What was that? Seco cosi, that was the what? Sine of A minus B. Yep. In this case, plus B. So what would you write? Sine A plus B. And that is equal to the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. I know it's kind of strange, but look at that. Now, these match to this. What is A equal to? What's A? 2x. What's B? Well, that one's a little trickier. That one's a little bit trickier. We're going to actually have to draw a triangle for this. And it says the cosine of B, actually this is B, cosine of B is 1/2. The sine of B is the square root of 3 over 2. Go to your unit circle. And which point goes over 1/2 and up square root of 3 over 2? What angle is that on my unit circle? It's either pi, yeah, 60. Pi over what? Three. So this angle here, to get 1/2, the cosine of pi over 3 is 1/2, and the sine of pi over 3 is the square root of 3 over 2. B becomes pi over 3. Whew, is that a lot of work? Huh? Well, we're not even done. Now we got to graph it. Okay, but no big deal. We can graph it. I'm going to steal you and move to 30 here real quick. And I would like you to do me a favor. We're going to take out a 3, and that's it. I'm going to leave cosine 2x times 1/2 minus sine 2x times square root of 3 over 2. Forget about that plus 6. Just leave that plus 6 alone. Could you write this in some kind of a something A minus B form? See if you can do that. I know it's hard, but you can do it. This is going to be of the form sine, no, not sine. Coco CC is which one? Cosine A plus B. Because of this minus sign, it's going to be A plus B. So that Coco CC is the cosine of 2x times the cosine of something minus the sine of 2x times the sine of something. Okay, so we got to find out what that something is. We'll call it B. What's B going to be? Well, the easy one is, what's A going to be? What's a perfect match? 2x. So that arc length is just going to be 2x. So we'll put that in. 2x. That's good. But the second one is a little tough. The cosine of B now. The cosine of B is 1/2. The sine of B is 1/2. So we're going to make a triangle here. The cosine of b is 1. Oh, wait a minute. Is the cosine of b really 1/2? And the sine of b square root of 3 over 2? Isn't that going to be the same as what we had before, pi over 6? Cosine is 1/2. Sine is square root of 3 over 2. Isn't that just going to be pi over 6, pi over 3 again? Yeah. So b is going to be pi over 3. So in the first one, you're going to graph sine of 2 times x plus pi over 6. In the second one, you're going to graph cosine of 2 times x minus, right? Nope, that's going to be plus pi over 6. So these are going to look very similar. Here's your a as 1, your b is 2, your shift is pi over 6. So we'll start with the sine curve like that. And it goes up to 1, down to -1. And then 1 period, b is 2, so the period is 2 pi over 2, which is pi. So this is just going to be pi over 2. This will be pi over 4. So if it moves over pi over 6, it's just going to move to the left a little bit, like that. Is that good? And then I'll leave this one up to you. I don't think you'll have trouble with that. And then for the last one, number 5, what you do is a population of butterflies. I'm going to write it this way. P is equal to 2 sine 3 pi over 8 times t, and then plus 3. This is going to be my A, B, there is no C, and this is your D. So A equals 2, B equals 3 pi over 8. Well, that's pretty horrible. And C is 0. D goes up 3. Okay? So the period is the only thing we have to calculate. Period is 2 pi over, is that 3 pi over 8? Wow. So this is just going to be 16/3. The period is 16/3. All right, and by the way, sine starts out 0. Sine of 0 is 0. So there you go. And then we're going to move this. We'll do that up part later. This goes up to 2, down to -2. And then we're going to move this whole thing up 3. So this is going to be kind of nice. This is going to be from 1 up to 5, right? And the middle is going to be, what's the middle going to be? 3? Okay. And then one cycle was 16 over 3. This will be 8 over 3. This will be 0. I think we got it. So what is the initial population? What is the population at time 0? What is it? How many butterflies? You have 3,000. Yep, 3,000. What's the largest that you have? Goes up to 5. What's the smallest? Down to 1. So 5 is the largest, 1 is the smallest. When does the population first reach 4? Okay, I don't expect you to know how to do this, but, Elizabeth, but what we're going to do is we're going to do this together. Would you write this on this slide? P is going to be 4, equals 3 plus 2 times the sine of 3 pi t over 8. Now you can use your calculator to find this. I have no problems. You just put this in your calculator and then you set it equal to 4 and see where it matches. But we're going to do it a little differently. We're going to actually solve this algebraically. So everybody has this written down? What would we do first? We're solving for t, but what do you think we're going to do first? What would be super easy? Subtract 3. So if we subtract 3, you're going to get 1 equals 2 sine 3 pi t over 8. Now be ready to be dazzled. This is going to amaze you. You're going to like this. How many of you know what's coming? Don't know what's coming. Okay. What should we do next to solve for t? Divide by 2. Like it? So you have 1/2 is equal to the sine of 3 pi t over 8. Now this looks completely horrible, doesn't it? But it's not, because covering this up, when is the sine equal to 1/2 on the unit circle? When is the sine, or the y value equal to 1/2? What arc length is this? It's on your unit circle. What do you think it is? It's either pi over 6 or pi over 3. It is pi over 6. No kidding. This is what we're going to do next chapter. This thing here, if this were pi over 6, let's write it in. If this were pi over 6, is the sine of pi over 6 equal to 1/2? It is, isn't it? So let's just say that then. Pi over 6 equals 3 pi t over 8. Would you solve for t now? That's the only tricky part, what I just did. And don't worry about it being on a test. You'll be able to do that for next chapter. But I'm just giving you a glimpse into the future. I can see the future. It's right there. So if you covered it up, the sine of pi over 6 would give me 1/2. So why not forget about all this junk and just say that 3 pi t over 8 is 1/2. And so the pi's will cancel. You're going to get 8, let's see, over 6 times 3 is equal to t. 8 over 18 is just going to be 4/9. Anybody know what 4/9 is as a decimal? 0.44444. In Boston, it's 0.44444. Here it's 44444. What is 7/9? 0.7777. What's 8/9? 0.88888. What's 9/9? What? 0.9999999 to infinity is 1? Is that what you're saying? Yeah, it's true. We'll look at limits next year in calculus. That's it for the butterfly.